Alright everybody, welcome to another Living Freestyle real-time dev live stream. We are working on Unreal Engine, blueprints, visual scripting, virtual production, virtual reality, augmented reality, all the cool stuff. This is basically set up like a Q&A, come and go, ask questions. The general idea is somebody's here to help you stumble through and troubleshoot some of the stuff you're working on, or just answer questions in general about development and all those kinds of things. My name's Kevin. We do this twice a week. I currently work as a senior principal tech artist at Riot Games, and usually what I'll do after each of these videos is I will go back through and I will log each of the questions so that we can make them discoverable. And the overall idea is that hopefully we'll build up a library of just some good resources for everybody to access. Now, got a couple things. I forgot I'd flipped my camera, so let's just fix that real quick because it's bugging me. And then we're going to hop kind of straight in. We did not have any specific questions that were sent in. We do have a couple that kind of came in that we'll just kind of go through and see if we can't knock them out. Lucian, good to see you. There we go. So Lucian's hopping in with some Discord questions to save us. Thank you very much for hopping. I hope you're doing all right today. Let's see here. So a couple other things to get sorted. Let me get my desktop laid out proper so that we can share all this stuff, and then we'll hop right in. Okay, now let's take a look. First, since Lucian's here, let's just take a look at what Lucian's question is. All right, so Dash. So just for context for everybody, Lucian was working on root motion based dash versus implied force dash and all those kinds of things. So we're talking about kind of abilities and specifically about getting a dash system going. So the dash kind of works, but the problem now is I want my character to travel a fixed distance and have their z vector maintained whilst dashing in the air, so they are not falling during the dash if they're airborne. Here's the code. How will I do it? Aforementioned stuff. Okay, so real quick, this is the ability tree, or the ability that Lucian's working with. Pretty standard, you know. We've got our activate, our commit. We're doing for the weight. We have our dash, our direction. We're applying the root motion. All this stuff. All this looks great. So all we're missing is the in-air component of it. Let's do this here, and we'll do this over here. Now, to do that, there's a couple things you could do, and I've seen it done a couple different ways. But one thing you might want to try is, let's see, do you have? Yeah, you can just turn off gravity for this actor if they're in the air. They won't fall. So one, you can turn off gravity. Two, you can do it like, you can basically just use root motion to do it, drive it straight with the root motion. And I'm pretty sure I'm doing this with, hold on, let me find it. I'm adding a slight impulse, but if you want it to be perfect, that would be different. But let me see if I can find this real quick. I'm doing this with the Great Sword, I believe it is. Great Sword. And, oh no, it's the combo. So here's our Great Sword combo, which uses our melee base combo, which uses a whole lot of stuff. So let's just dig in here. So this is launching the character. Set timer by event, stop movement, playing the montage. This is the closed target gap. Make it the normal. Sorry, I'm just looking for this. That's the teleport, that's not the dash. So teleport would absolutely do that, and that's how I do the effects. I think I've done this a couple different ways, and I think actually I thought I had an example of it. But basically, what this does is effectively all you need to do is check to see if you're in the air. If you check to see if you're in the air, there are multiple things you could do. So if you're going to control it specifically, you could just calculate the vector, transform the character along the vector. Another way you could do it would be just basically add in the pulse, but disable gravity, so the character isn't going to drop at all. And then what I was doing here was basically, if you're in the air and you swing your sword, it is going to give you, it's going to add in a Z vector value for your character that's going to keep that character in the air. But this is going to cause it to have a little bit of an up and down, right? It's not going to be a perfect straight line. So it sort of depends on your end goal. But in the big thing though is in the ability, right here in the ability, just like you, I have the commit, I do all my casting, I'm broadcasting some messages, and right here I'm launching the character. So right here you could try disabling gravity. That would be the first thing I would try. Depending on how you're controlling the character. Yeah, you're applying a root motion constant force. I think you just need to disable gravity. It might be that simple. Could you give that a try and see? Okay, so while Lucian gets back to that, I just want to recap some of the other questions. We had just a general question about C++, and it was DJ Angelicon was just basically, you know, can you learn C++ from Unreal, or is it better to get another training source that focuses on C++ instead? Now, this is less about Unreal and more about a learning paradigm. And for me, I think that my answer to this largely depends on what your goal is. So if your goal is to be a character modeler or a designer or a concept artist, then no, I don't think you should be learning C++ for Unreal Engine. However, if you want to make your own games and you want to have an additional skill set that is actually very useful, being able to hop in the code and figure out what Unreal is doing in the code, even if you're not a master guru programmer, but you can at least read it and see what's happening, it's highly useful for trying to figure out what is happening in certain situations. So that's another good one. And then generally speaking, it sort of comes down to what type of learner you are. So what I mean by this is I have friends who, when they sit down to learn a thing, they have to learn it. They have to read the whole book. They have to know it start to finish. And yes, in those cases, those friends, they take a class, they become a C++ standalone expert, and then they can use that and apply that. I am much more of a learning in context kind of person. So for me, I would rather say I want to learn C++, and I'm going to use Unreal Engine as the backdrop in which I'm going to learn C++, and even further, I'm going to have a specific goal. I want to build a game that does, you know, a platformer, or I want to build a 3D game of some type, and then what's going to happen is I'm going to learn the C++ along the way, and specifically what I need to achieve that goal. It helps me stay focused, and it helps me problem shoot this stuff a whole lot easier. So that was another one of the questions we got. And then we had a really good one from Lucian, actually. Lucian, I'm going to just kind of recap your timeline question, because that was a really good one that I think people get stuck on sometimes. So Lucian was asking about basically they were the precursor to our current gravity-z question was they were trying to build a dash in the gameplay ability system, and the problem with the code is that in the tutorial they used a timeline node to lerp between start and end positions. But you can't do that in a gameplay ability. The reason you can't do that in the gameplay ability is that gameplay ability doesn't really have a sense of time. It's not meant to be used by that. And that's why it's not available. So there are two potential interesting ways around this. Okay, one is to, for example, you can create a, I believe it's a gameplay ability actor, and the actor does have a reference. It's probably not what you want. Or the super cheat that I've used in the past is I actually have a timeline actor that I spawn and reference and destroy at the end, and I get all of the info I need from that timeline actor in the ability. But in general, that's not the way it's done, but it's worth throwing out there that is a possibility. Okay, so with that, it looks like we've gotten through all the questions. So let's take a quick little break and let's kind of do a development update. And the development update is I have completely started an entirely new project. You didn't really see a difference when you tested it. Okay, hold on. We're going to pause our development update. Let's go. Let's see if we can solve this gravity thing. First we need a map. Let's use our test map. Sorry, I was working on something else. So let's load up the playground. Sure, let's save that. And then let's disable our enemies so we can focus while we're doing this. So no enemies. And no bad guys. Okay, and right now, when I play, if I jump and I swipe my sword, you can see as long as I'm clicking, the character is staying in the air. And that is just as a result of that launch, right? If the character's in the, oh, I get my usual break. Hold on. So if I jump, if the character's in the air and I swing, it basically gives me just enough of a launch that I stay in the air. But let's try that a different way, okay? Let's do this. If we're in the air, let's get the controlled pawn and gravity. Let's try this set, and then we're just gonna have to play with this. So rather than launching, let's just disable gravity. Let's see what happens. Should be wild. Okay. That definitely did not work. So that's not it. So it's definitely not on the mesh. To your point, let's try the movement. Get movement. Hold on, I need to remember what our character has in it. Let's look at our shooter mannequin for me. Shooter mannequin. Okay, so we do have a character movement. So let's go back to combo base. Do we have a handle to a... We do. Interestingly enough, I'm not storing that, but we can just get it from here. So let's get movement. So here's the movement component, and let's check gravity. Set gravity scale, set it to 0. See what happens this way. Okay. So if I jump and swing, so gravity is no longer enabled. Okay, so now when my character moves, you can see it maintains perfectly where we are in the air. So I think that's working. I think that's working. And then obviously you'd want to make sure that you re-enable it. But did that work? Does that work for you, Lucian? Let's see. I think you'd probably set up some kind of flag so that when your ability ends, you make sure you re-enable that, or that section of the ability, obviously. Now I am going to reconnect my stuff. Because that's not what I want to do here. Oh, no, that's not the right one either. This is the right one. Here we go. Okay, so now our blueprint is back. I should, oh goodness, did we just crash? Oh goodness. I think what I'm going to do is from now on for our streams, I'm going to go ahead and commit everything before a stream so I can always get back. Yeah, give that a shot. The other thing that's kind of along these same question lines, Lucian, while we're in here, is I do have a teleport. So how this works is Original 9, welcome to the stream. How's it going this Sunday? So what, similar to disabling Z and moving along, here, let me show you. Let me just show you what this looks like in play. If I go, let's delete our door. Yeah, that's fine. Let's delete this door. Delete the trigger. And then let's create an enemy, because I need an enemy for this to work. These are lights, spawn points, team 1. Okay, so the way this works is if you tap right click and you're in the air, you'll see that I will teleport to the guy. And it has a similar feel. Back up. See that? So it's like kind of like a quick dash teleport that basically, if they're within range and targeting, it'll dash me basically back to a teleport. And then here, let's do this. If we go slow-mo, I'm gonna slow-mo this down. Let's go slow-mo 2.5. You can see I disappear, but then a bunch of effects play, and then I reappear. So how's that all happening? That's all happening in this greatsword, in our melee base. What happens is, based on targeting, I get locations of where we're going, etc., etc. And then I execute a gameplay cue, right, which is our dash to target. Then I teleport. This is our camera modes that I set up, and everything like that. So basically, I turn the character off, visual character off. Hold on a second, I'm trying to remember how to talk. So I turn the character visuals off for a second. Then I spawn the dash effects, which is the blue, cools, misty stuff. And then teleport. And as you're teleporting, effectively, the particles are going with it. So you looks like you get this nice line trace. And then I turn the character back on. That's just part of our built-in stuff. So maybe that might be another cool thing. I'm doing well. Did you have any questions for us today, Original 9? Okay. While we wait for more questions, I am going to go back to doing the quick development update, because honestly, I'm super excited to show you all what is coming. I'm not going to say that. I'm not going to say that. I'm not saying that. Okay. So I kind of hinted that it might be fun to try to do a platformer, and I think Lucian, you'll get a kick out of this as well. So I was like, all right, let's make a platform. And so I started doing some work, and I started building and learning all about platformers. And I basically went through, started, basics. How do I spawn a character? How do I make them run left and right? How do I make them jump? And I've been just kind of going through this little by little. Now here's the kicker, okay? I have completely different key bindings, etc. The kicker is all of this is also being done with the game playability system, which is fun. So for example, this character is able to jump because I created a gameplay ability for the character to jump, and when you press spacebar, it activates the ability and goes from there. So it's kind of a fun, I don't want to say less complicated, it has its own type of comic, but it's kind of a fun way to do it. So, and also, along with the abilities, the character has the ability to fire. And so, I created, so now, as part of our platform, we can shoot our enemies. And this ability is called Death Blossom. And I've been just kind of slowly working my way through all of the learnings of a platform. I'm pretty excited about it. And most recently, I figured out death. So there I died, and I respawn. So this has been a really fun kind of like fast-paced learning for the just gameplay ability system, how to things and troubles, platformers, etc. So this has been a lot of fun to kind of go through. So quick development update. I'm taking a pause from the 3D stuff. I think this is going to be a fun little project to work on. And also I'm even kicking around the idea of all of us launching a thing. It's like, let's ship a game, like let's actually make a platformer and ship it. I don't know, put it on Steam, wherever we're gonna do it. I think that might be a fun video series to do. So obviously I need to learn a lot before we do that, but anyways, that's my quick little development update. With that, let's go back to questions, and if we don't have questions, then I will go ahead and answer or pose some of the questions that I am currently facing in my own development, and we will try to answer some of those. So F-Zero, I was thinking more like Hollow Knight or Dead Cells or whatever. I gotta look up F-Zero. I haven't looked at F-Zero yet. F-Zero. Yeah, but that's so F-Zero. You're talking about the racing game? That one's a little bit more. I'm talking more like, yeah, like Dead Cells, Hollow Knight, even Mario. Mario is a great example. When I say platformer, that's kind of what I'm thinking about. And the way, and part of it, the inspiration for that is, I mentioned this in one of the previous streams. We did a game jam, Thunderdome we call it at work, where basically you get, it's effectively 3 days total, but you have to count starts and stops and presentations, everything like that. So you basically get 2 days, and in those 2 days you can work on whatever you want. And one of the things we used to do is we used to make a game. Can we make a game in 2 days? And one of the games we made was Zig's Arcade Blast, and you can actually download and play Zig's Arcade Blast. And the cool thing about that Thunderdome was, the goal of that was, can we make a game, actually ship it to players in effectively 2.5 days? And we did, and it was amazing. So I think we had like 40 people on that project, and I don't think I slept for the entire time. But let's just take an average of 40 people, and let's say that they worked 20 hours, so 10 hours a day each. Let's just say they actually did longer days. Say we did 15 hours. So 40 people times 15 hours times 2 days. So that's 1,200 hours. All right, if we divide that by 8, okay, that means that as a single dev, you could potentially ship a Zig's Arcade Blast type game in 150 days if you were to work on it for 8 hours a day. That still seems nuts, okay? I'm not gonna lie. Still seems like a lot. Like, we're talking about half a year here. And also, you have to remember, the people who were working on that project, like, top of the game, right? Top designers, top artists, top engineers, everything you need. Plus, they're working on an infrastructure and a backbone that already exists at Riot to help make that happen. But the point is, I don't know. I might just be just the right amount of crazy enough to say, I think we could do this. Let's ship a properly scoped platform, right? And we'll just make a video series about it. Okay, so Lucian has a question. Do you cast to store a reference to the character inside your gameplay ability, or do you use interfaces to do it? I'd like to avoid casting as much as possible. Okay, so this is a really good question, and there's some performance parts to this. I think there's a couple answers. In general, depending on where I am in the production phase. Like if I'm in prototype, I don't care. I'll cast, do what I need to, get it, test it, work it, make sure it works, and then go from there. The thing I have not tested is there are certain things. For example, if your character, for example, let's say your base character is character base, and the movement component is in there, and you're working on something with the enemy. Don't cast to the enemy if you need your movement component, right? Because you can just get the movement component from the character base and you don't have to do that casting. Absolutely. What I have not tested is whether or not, I don't know the performance differences between a blueprint interface versus a cast. And I would have to do some research to try to figure that out. Because with a blueprint interface, what you're going to have to do in your gameplay ability is you're going to have to do some kind of check. You're going to have to say, does the character implement this interface? And if it does, call this function. Well, the thing is, that if statement, does it implement this interface? I don't know. Is that chain of events faster than just doing the cast? So does this actor implement the interface? If it does, then do the interface. Then on the actor, it would do its thing and do that communication back and forth versus just casting to it and executing it. The reason I mentioned that, in one of my previous lives, in one of my previous lives, I used to be a high-end graphics engineer for high-end video drivers. And it was all about the performance. Like basically, and think of it like NVIDIA cars. That's what I worked on. I used to work on software drivers for NVIDIA cars. And when you were doing all of the stuff on the chip level stuff and the software drivers, every if statement made a difference. And to the point where we didn't even use if statements. A lot of times it was so nuanced that we would use actually bitwise operators instead of if statements, because the actual execution of doing the if test on zeros and ones was faster than the actual if statement itself. This is for performance code. So depending on how hardcore you want to be about this, Lucian, I think you could definitely implement an interface. Doing so, I don't have an answer specifically about the performance differences between a blueprint interface versus saying, does the actor implement the interface? If so, do the thing. So we would just have to take a look at that. Let's see, was that a question that just popped up? Let me check. No. Alright, let's have a quick look on. Things are quiet over on Twitch today. For everybody who's in Southern California getting ready for the rain. You know, hopefully you've gotten everything all battened down and ready to go. For everything else, okay, so we got our cast. Hopefully, was that a good answer for you, Lucian? Does that help at all in your decision process? We can do a quick search. Casting in Unreal Engine versus Blueprint interface performance. Here we go. From Unreal Engine directly. Oh, no. I'm getting some good answers. They're very different. Apparently there's a lot of threads about this. I'd have to do some more reading, but there is no definitive, like, absolutely, Blueprint interfaces are faster. The casting does cause a hierarchy of dependencies. That's true. We've talked about that in previous streams, which does impact load times and memory footprints. So, looks like interfaces over casting, maybe? Never cast in any of your behavior trees. Decorators, services, and tasks causes circular dependencies. So good stuff. Speaking of blueprint interfaces, based on the blueprint interface conversations that we've had, I am going to record a standalone blueprint interface video just to kind of recap as a standalone piece, just some of the stuff we went over during one of our live streams. And I think we're just going to add that to the fundamentals, the crash course to visual scripting for creatives. So there's all the basics, for loops, variables, all those kinds of things we've talked about. We've talked about classes. I've been trying to figure out like what's the next big gap. I think blueprint interfaces is the next big one. So we'll do a video on that. Yeah, and I mean that's kind of what they said. So based on quick reading, but I've also been told it also depends on where you're casting. But if you can just get a reference to the character itself, like if you're going to store a variable and you know here's a great example. Let's say you have a blueprint and you do need to know that it is a character base, or let's say a character enemy. If you know every single time it's going to be an enemy, make your variable an enemy. Don't make it a character and then cast an enemy within that blueprint. Okay. So how are we doing time-wise? We're doing all right time-wise. All right, so again, as always, questions take priority. If you all have any, keep them coming. Go grab your friends, throw some questions in. In the meantime, what I'm going to do is I'm going to show you a problem and we're going to see if we can fix it. So notice how this projectile, when it shoots vertically, it sometimes wraps around the enemy. Okay. Well, the problem with that, I was too close. It was a little too close. The problem with that is, I kind of want my character to always hit the enemy. And the reason this is happening is because I can't even get close enough anymore because I'm dying. Oh, but this is cool. This is the ability system. Hold on. So let's escape out of this. Let's go down to our abilities for this character. So here's our hero data. It's using this ability set. And inside this ability set, we have death. Can I either turn this off by setting this to 0? Nope, I have to remove it. So let's just remove death. So I'm going to remove death as one of the granted abilities for this thing. And actually I'm not going to leave this as none, I'm just going to delete it. Okay, now at this point we have removed the ability theoretically for this character to die. Cool. So now I can actually show you the problem a bit easier without worrying about it. But you see how these are circling around? I mean, it looks kind of fun and cool as long as it always hits. Now, there's two different ways to do our hits. Well, there's way more than two different ways, but a way to do the hit is we could do a line trace straight from our character to the enemy. If it doesn't hit anything, it hits. That's one way. It's often a way that is used in server authoritative stuff. Or, for example, in this particular case, the way this works is the projectile that spawns, that is doing the flying around, if it hits, whatever it hits, it will do damage to it. But the problem is, I almost want to guarantee it hits a little bit better. And there is a problem where when we get this close, like if we're way back here, it hits the character every time, never misses. And that's because of the homing projectile. So what happens is, the problem is, the speed at which we're sending the projectiles out needs to get lower as we get closer to our target. That's my guess. So this is my theory. So here's the question. How do we slow down our projectiles based on distance? And also, does slowing down our projectiles fix this problem? So let's divide this problem question into two parts. So if we come into our weapons and we look at our Death Blossom, this is our Blossom. When it spawns, after, we definitely need to clean this up a lot. This is our min float. Here's our homing magnitude. We're setting that it's a projectile. And this is where we set our velocity. So let's just test this theory. If we slow our initial projectile down, we should be able to always hit. So let's go down to point. So this is just to prove the theory that slowing down the initial projectile velocity will solve our problem. So let's try that first. Yeah, so we can't miss it. And that's because basically the projectile goes straight. It just goes straight at them. Okay, so it would make sense that as we're further away, we're way back here, that we can have those nice arcs and swirliness. But when we get closer, we want it to go down. So let's reconnect this. Actually, let's keep this. And let's do this. What do we have in here? We have projectile, it's homing. Do we have the other actor? We have to have the other. Yeah, here's our homing target component. Instigator. Wait a second. Ignore actor. Hold on a second. Our projectile movement, homing target. Homing target component is component by class that's gotten from the target actor. The target actor is set here. Okay, perfect. So what we can do is we can just say somewhere in here, let's get the location, get the actor location. Wait, distance? Is there a get distance too? Like so we have this nice get distance too. Let's get our other actor, which is going to be the instigator. Okay, now what we're going to do is we're going to use this as a means. So let's reset this to 1 for now. And when we do this, let's just do a quick print string because I want to see what the numbers are. Print string. So let's print string on this. So now when we shoot our missiles, we should see the distance. So that distance was 1743, 1000-ish, 300. So the idea is when we're at 300, we would want to reduce our velocity by a fair bit. Okay, so let's say let's go back in here and think about a little bit of math. And this math always hurts my brain because what we want is we never want this to be 0. So we probably could use a clamp. So if the distance is 300, we want our velocity to be 0. So let's divide by 300. Let's just divide by 300. And I have not finished my thought yet, so that's not gonna make, so if we come in here and our velocity is, our distance is 300, we divide by 300, we get 1. So let's subtract. And we're gonna do a 1 minus on this. Okay? So what's gonna happen is, if it's 300, we divide by 300, we get 1. 1 minus 1 is 0. Okay, and then let's just add, let's add, or no, let's, we can add 0.1, hold on a second, let's clamp, let's do a clamp first. I'm gonna clamp a float. Max is going to be the distance. And the min is going to be not there. Let's go min of 0.1. All right, so when we're 300, 1 minus 1 is 0. It's going to clamp it to 1. When we're 400, let's see if this is going to work. Where's my calculator? Calculator. 400 divided by 300 is 1.33 minus 1 is 0.333. Let's just see if this works. Connect and go. And then when we're at the distance, it's 1. So it's basically, okay, so not quite. What is it multiplied by? So if our distance is the initial 1700, 1700 divided by 300 is, where did our calculator go? 1700 divided by 300. 5.6. Oh no, we're doing this wrong. We don't want 1 minus this. Oh gosh, y'all, all we want to do is normalize this. Somebody help me with this math. $1,700 divided by 300. I think we do want, I think we want to flip this. What? Minus 1. I'm gonna have to do some drawings. Okay, if we go 1 here, 1. Let's just make sure this still works. Okay, so when we're at 1, we're fine. What we want is when our distance to the target, somebody help me. All right, let's just break it down. If we're 1,500 units away, we want it to be 1. Okay, so that's our max. And we basically want to take the entire range. There we go. So we want to take 1,500. We want to subtract off our minimum, which in this case is 300, I believe. Okay, and then we're going to divide that by 100, I think, depending on how much you do this. So if we have 1,500 and we subtract off 300, that's 1,200. 1,200 divided by 100. 1,200 over 100. 12. Man, this is not. I'm not thinking about this right. Is it because it's Sunday? Okay, let's draw. When in doubt, get out a piece of paper and draw. so let's start a Photoshop file real quick. Photoshop. Oh, we already have one. Let's create a new file. Sure, that's fine. Just create that. And then let's do some drawing. Here's what I mean. Okay? We have our paintbrush. We have our character. We have our target. Alright. Now, we know a couple things. We know that at 300, why is that? We know at 300, we want the value to be 0.1. Alright? And let's just say that this is 1500 here. Wait, why did I write it up there? That's a bad place to write. Background color, please. Okay, so back here we want it to be 1500. So at 1500, we want it to be 1. Okay, and then basically all along the way, these are going to be different points. So the question is, what is the math to do this? So 1500 divided by 1500 is 1. 300 divided by 1500 is what? How do I keep closing the calculator? 300 divided by 1500 is 0.2. So this isn't really, it's 1200 divided by 1500, 0.8. Oh, it's because this distance. Wait a minute. So this is, it's the distance to the red mark. It's the distance to here. That's the 1500. So effectively, we're not dividing by 1500, it's 1200. What is 1200? What is 300 divided by 1200? 55. That's not the number we want either. What the world is going on here? This total distance is 1200 units, right? Yeah, 1200 units. Oh, you're at 0. Oh, okay. Okay, so from here to here, so this is 1500, this is 300. This total distance from here to here is 1200. Okay, we need to ignore the 300 and the 1500, and we want to use the 1200. And that's basically going to be our range at 1200 units. So 1200 units, we want our power to be max. So we get our distance, we divide by 1200 out here, and we get 1, for example. We can max out at 1. So at our distance 1500, it's going to be 1200. And then if we're at 300, and we divide by, I think it just needs to be fixed. It's a fixed range. So we take our distance, we divide by 1200. Take our distance minus our buffer, divide by 1200. And then we take that, and we're going to go 1 minus on that. And then we're going to clamp it. And then we're going to feed that into here. So theoretically, when we're at 1500, 1500 minus 300 is 1200. 1200 divided by 1200 is 1. 1 minus 1 is 0. the value is going to clamp for instance. Okay, so we don't want to do the -1. We just want to do this. Let's try that. Maybe that's it. If that made sense to anybody, it's a miracle. It definitely didn't work. That is for sure. Okay, the closer I am, y'all, I'm down a rabbit hole. What? I thought this was gonna be super straight ahead. Print string. Good old buddy. I want to print what it's saying it is. When we spawn, it's -0.2. If we are within a certain distance, it's 0.8. So we don't want the 1 minus. When we spawn here, 1.2, 0.5, 0.19. Okay, so this value gets fed into our clamp. Our max is going to be, let's change our max. We're going to go, oh, dude, I think we were multiplying by 0 the whole, oh my gosh. That's all it was. Okay, I think that's all. So I'm going to undo and show you what was kicking my butt. The math wasn't off. I mean, it was off. It was confusing. But if I undo just a couple steps, you see this distance 2 I was feeding in here for our max? There's nothing plugged into it. It was multiplying by 0. Why? Why? But we basically just need our max to be 1. There's no reason to do it the other way. Okay, so to recap, what should have been a very easy question, or straight ahead, is we wanted our character so that when they are shooting, the death blossoms will take this nice arc. Okay, and as we get closer, the arc gets tighter, so that they're no longer spinning around this guy. It just hits straight away. Right? The further away we are, the more it is. Alright, which is cool. That looks great. Now what we could do is we could actually we could change this. So we're taking, if we go back to this is 1200 units. If we wanted this to be stronger out here so that we get more of an arc, I think that might be an exponent power 2. Try power of 10. Oh, but their max here is 1. Let's do 100. Okay, let's try exponent of 4. I don't think that's necessarily changing so much our speed. This is feeding into our new velocities. Oh, we do have maxes here as well. This is kind of controlling it. If we go 40,000, well, this could be wild. This might be way too much. Oh, but it works. It totally works. So we have a max of 40,000. So we're getting these But what's happening is, because our distance-based tapering of the velocities is actually working, this amount of the swirling is happening because we're using 40,000. Like, it's just huge. If we were to knock this down back to our 20, we should never miss. So there's going to be like a tolerance threshold here. And we'll go, let's try 2. And if we wanted to favor vertical, we could go more like 4,000 here. And what's going to happen is we should get most of our shots. We could probably even go something like this. I think that's positive. Yeah. So all of our shots are happening. So basically, based on how we tailor our shot, our mins and maxes here, we can kind of control which way our projectiles are going to spawn. So after a significant amount of stumbling through math, the general gist, or the overall idea here is some means of tapering the initial velocity of our projectiles as we get closer makes it in a world where we no longer miss our enemies, right? And the further away we get, the prettier this stuff looks like. So I thought that would just be a fun thing to answer, and it also has gameplay implications. Now, we are actually getting close to the end of our time here, and one of the things that we're going to do is, right now you'll notice the enemies don't die. So for next time, if we don't have any questions, I am going to go over making the enemies die as well. So that will cover that. Let's just double check Twitch, a couple of our streams, and then we'll get into wrapping this up. All right. I don't see any other questions on Twitch or any of the streams. Let me double check Discord real quick, make sure there were no last minute stragglers. Looks good. All right, Lucian. Yeah, hit me with a question. I'm happy to hang out. Let's do it. What do you got? For anybody else who is hanging out and, you know, stream into the stream, you want to take off and stuff, it's totally cool. Thanks for hopping in as always. You know, if you dig what we're doing, if you like what we're doing, help spread the word. You all know how to, you know how to get the message out. If you have friends who are also struggling with Unreal, or if you have fun watching me stumble and faceplant my way through simple math, like, tell people about what we're doing here, and hopefully we can just kind of build up a community to a point where what happens when we get to a critical mass is we will have this really cool collection of people who are into helping each other out and problem solve. And the power of that when you're trying to troubleshoot stuff is amazing. So I'm looking forward to that. So getting back to Lucian's question, it's kind of working after trying your suggestion. Now I just need to travel a set distance. Okay, you should be able to do that. Do you know? So the easiest way to travel a set distance is do you have either a rotator or a vector? If you have a rotator or a vector, normalize it and then multiply it by your distance value. So let's say that you wanted to go 300 units and you have a vector, or let's say I want to travel from here to the door. The door is 1,000 units away. I have an ability that lets me teleport in the air 300 units. So I can't go all the way to the door, so that's not going to work. But what I can do is I can get the vector from me to the door. So I do that by subtracting the door's position from mine, right? Me from the door. This is a better way to say that. So now I have a vector that goes from me all the way to the door. So, and with vector math, let's just say the door is, just for ease. You know, basically with vector math, once you have a vector the full length, just take it and normalizes it. What that does is that take your really long vector from me to the door and shrinks it down to 1 unit, makes a unit length vector. And the great thing about a vector that is 1 unit long is I can multiply it by any number, and now I have a new vector that is the exact distance I want to travel. So let's recap this. Let's recap this a little bit differently. Let's go do some drawing. Okay, so we'll share our screen real quick. Let me just double check that this is working. Okay, it is. Cool. So what we've got is we've got ourselves and we have our target. Okay, and then we have a vector. Oh, I see what you're saying. Okay, well, let me finish this. Let's say that this is 1,000 units, but I only want to go 300. If I normalize this vector, it gives me a new vector that is 1 unit long. And then if I multiply that by 300, okay, then I will end up with a vector that is 300 units long. And what you do is you just take this and add it to your initial position, and you have a spot that is right here. Okay, now Lucian's question about root motion is really good. Let me bring back, where was I doing that? Dash. Let's look at hero dash. Hero dash. Is it hero dash? Gameplay ability hero dash. Strength. Oh, interesting. This becomes an RTD problem. Rate times time equals distance. So you're gonna have to, let me see, hold on a second. Let me go back to, I think what you need to do is, I believe the answer is you have your direction, and you have a strength and a duration. So what you have to figure out is, hold on, this target is apply force to character's movement. So if you applied, if the duration was 1 tick, you have your direction, and your strength was 1. Hold on. We just need to figure out what force they're applying here. We could try it. I mean, let's just try this. Let's just play with our dash. Let's load up the level real quick. We're looking for our... I don't have dash on this character, so I have to load up a different map. So if we take a look at our playground, this is going to be fun. Sure, we'll keep that. We'll keep the blossom. Melee combo base, we're not going to see. Okay, and then what we're going to do is, let's just test our dash real quick. First things first, let's take and turn off our enemies. Okay, and then let's just play, and I believe dash I have on tab, or yeah, tab. So Each of these boxes is so that's going like 1, 2, 3, 4, 5, 6 boxes. Okay, so let's go to our dash. And where is strength being determined? Is it just being passed in? It is being passed in. So if we change our strength to 1, what does that do for how far we travel? We can basically reverse calculate this, I believe. It looks like it went 1 meter. You see that? It's kind of going 1 meter. So let's change our strength to 2. Do we go 2 boxes now? Pretty much. It's pretty close. That's 2 boxes. Alright, let's continue our test. Let's go 3. One, 2, 3. Oh, that's it. Evade. Oh. It's hard to tell, but it's pretty darn close. It looks like your strength. What is our duration? Constrain on the duration. Because your time matters, right? Rate times time equals distance. So that's what's going to finally determine how far you go. 0.25. Now, if we wanted to get super hyper focused, or hyper, whatever, there's 30 frames per second, right? So 1 divided by 30, each frame is 0.03. So if we changed our root motion duration to 0.04, do we actually still travel? Because it's per tick. That's pretty consistent. That's 3 units. Wait, maybe it's not. Let's try 3. It might be because I'm holding the button. Let's go 300 units. 300 strength. We should probably just, you could probably enter it. I think I have to disable input to test this. Just like we do in let's try this. Disable. Where is that? Where do we do that? Disable? Nope, not there. Stop movement, character control. We just want to ignore that. Let's go hero dash. Do we have the character controller here? We do not. How did we get the character controller? This guy. Can we just do this? I'm trying to take out the... Okay. So that worked. Let's take this, and after we apply that, let's delay. Let's go 0.5. That way we're not actually, now we can actually see theoretically how much of it is from Okay, so that's how many units are we moving? 300? Let's try 1,000. Doesn't look like he's traveling very far. It's not units then. It's definitely not units, it's strength. There's gotta be math. Play. Oh, whoa, that was way further. Hold on. So we went 1, 2, 3, 4, 5. Basically, one, two, here. So if we go 500, 5,000, we go half the distance. Yes. Okay, so basically in one tick. Now here's the trick. If we double this duration to 2 ticks, we should go twice as far. If we're thinking about this right. We definitely did. Pretty dang close. Okay, so does that make sense, Lucian? Is everybody still here? Chat's gone. Wait, where'd the chat go? Somehow I lost the chat. There it is. Okay. So okay. So I think what this does though is you can figure out the distance. It makes this a little complicated from a designer standpoint, right? In the sense that it seems like you know exactly where you want to go to. You could theoretically take that distance, divide it by how long you want it to take, and then that would be the strength that you used. So for example, wait, yours is not working like that. Meaning you are not using the same node, or you're not using the supply root motion constant force? Are you using a different one? But if we reduce our time, we should only go half the distance. Which it seems like we do. So if we let's go 6. It should be 4 times as much. So we should basically dash right off this platform. Yep. Totally. So basically, an answer to your question is rate times time equals distance. So for a constant force node, the amount of time that you're applying the force and how much of the force that you're applying will change how far you go. So if you're going to apply the force over one frame, you need to use a bigger force. You figure out the distance, you use bigger. If you're going to apply it over multiple frames, and so on. Now, it's kind of, I think I would have to better understand your end goal. Like, if there's a specific point that you want to go to, you might want to use, and I'm not sure how it's set up, but like, for example, I think you can set up control curves, or actual like launch curves, we call them at work, where you determine how far you go based on a curve, effectively. And then rather than applying a constant force, you basically, when root motion gets applied, it basically follows that trajectory, however you lay it out. So I would have to know, but from an interesting learning standpoint, the way the root motion does work is it's literally based on your strength, the time for which you're applying that strength, and that is going to determine the distance that you travel. So it's a cool thing to know. I think if I needed my character to be in a specific place, probably would not use this. I would probably either use teleport, or I would try looking into launch curves a little bit more. I'm not even sure if that's just a general thing. Root motion based on curve. I'll do some digging to see if there's a controlled way to do that, because there has to be. So who's the root motion being applied to? What do we have here for root motion? Look at this, apply root motion, move to target data. Interesting. What else is available for root motion? I'm gonna have to do some digging on how you might set up a specific distance that you want your root motion to go. I know we do it. I know we've done it on a couple projects I've been on. I just don't know how it was done, and I will have to look into it. But at the very least, at least we understand how this root motion constant force works. Teleport is an option. I've got to think that there's a way to use either anim curves or something like that with a vector that you can actually drive that. And I'll just have to dig into it and see what I can find for you. Hopefully one of those will work. Alright, y'all. I think it's time for us to wrap this up. Lucian OG9, thanks for hopping in. It was good seeing you all today. I'm super excited about the platformer stuff and all of my gameplay ability system learnings in there. It's been fun to share with you all, so thanks for hearing me and letting me share that out. I'll be looking into getting that blueprint interface video going. I think we just need to round out some of our more fundamental training. So we'll do the blueprint interface, finish off some of our Python for Crash Course for Creative stuff. We need to get all of that stuff rounded out so we can focus on our next project. So I am not going to start Let's Make a Platformer until those other two video series are just rounded out and updated, because I've discovered in the last week of not sleeping that basically I've discovered that I get super distracted by the fun, cool stuff, and I want to make sure I finish out those other video series first. So I hope everybody has an awesome rest of your Sunday. Again, we'll be back Wednesday at 11:30 doing more of these questions. Once again, share it out, tell people what we're doing, get your questions in, and we'll go through those in the live stream. And Lucian, I have not forgotten. I am still trying to figure out how to properly set up Discord to be able to handle stuff like that. I may just start. Maybe I'll just start streaming at night when I'm working on the platform for fun, since I'm in there anyways. So, all right, everybody, take it easy. If you're in SoCal or you're dealing with storms or Hawaii or any kind of just fun disaster type stuff right now, you know, stay safe. I'll see you all in the next stream. Later.